Okay, I think we're recording. So what questions do you guys have?
Can we do the difference quotient problem on the UVU review?
You want to do that one? Okay.
Yeah.
There was 3 of them. Which one? Let's try to pull that up here. Which one do you want to do on that one?
Let's do C.
C.
Yeah.
Okay, let me pull that up here. I'll try to share. Alrighty then. That was one of the first problems, if I remember. Okay, so you want to do C, find the difference quotient. Okay, so let me paste it here. And we only cared about, let's see, find the difference quotient. Part C is 1 over x plus 3. Okay, so let's figure out, the first thing we need to figure out is what is f of x plus h? So can you help me do that, Logan?
Yeah, so would it be 1 over x plus 3 plus h? Or is it h over x plus 3?
The order doesn't really matter. 1 over x plus h plus 3, that's correct. Okay, so we're going to take that and then we're going to subtract off the original thing, which we have is 1 over x plus 3. I should give myself more room. I'm going to move this over here. And, okay. So I need to get, oh, and then all of that is divided by h. Okay. So how do we get a common denominator? What is the common denominator?
X plus h plus 3.
Okay. So I'm going to multiply this by that over that. I'm going to multiply this by that over that. Whoops. Okay. So my common denominator is going to be both of these here. Okay. 1 times x plus 3 is going to be x plus 3. And then -1 times that is going to be negative x minus h minus 3. Okay. So the x's will cancel, the 3's will cancel. I guess I forgot to put my h down here. The x's will cancel, the 3's will cancel. I'm left with negative h on the top. So negative h is on the top. I still have this as my denominator. And I still got the h on the bottom. Okay, what do we do next?
Multiply by the reciprocal.
Okay, so the reciprocal of h is 1 over h. So now the h's cancel, and I've got a -1 over this right here. And that's all there is to that. That's the answer right there. Okay. Can you guys do that on the file?
Yep.
Okay, I hope so. All right, what's your next question?
Can you explain one-to-one functions again? I forgot what those are.
Everybody know what a one-to-one function is?
The one that passed the vertical line test and the horizontal line test.
It doesn't have both. It's only got one of those. Which one is it?
So
Because that's this one here. Oh, no, it's not. It's this one here. Is it the horizontal line test or is it the vertical line test?
vertical.
Nope, it's the horizontal. So a function's one-to-one if it passes the horizontal line test. So is A one-to-one?
Yes.
How about C?
Yes.
How about B?
Yes.
How about D?
No.
No. D is not one-to-one. Fails the horizontal line test right here and here. It is one-to-one from, what is that, x equals -2 to about x equals -1/2. It's one-to-one down here. But everywhere, pretty much everywhere above the x-axis, it's not one-to-one. Okay? All right.
If it is one-to-one, does that mean it has an inverse?
Yes.
Okay. So yeah. Okay. Can we actually do one of those real fast then?
One of these? Do you
Yeah.
want to sketch the inverse function?
Yes.
I did this yesterday in my other class, and this one was really hard to do when you don't have a piece of paper. We'll do the easy one first, though. So all of these are one-to-one except for D. Probably, let me go back. I think paintbrush will be easier on this one. Okay, so maybe I'll make that a little bigger. Okay, so the idea is if it's an inverse function, this point here is what? It's -3, -3, -3. Everybody agree with that?
Yeah.
Okay. So if it's inverse function, we just flip the x and the y coordinate, which is, if we flip the x and the y coordinate, it's the same coordinate, right? It's still -3, -3. So nothing changes there. This point here is -1, +1. Okay, so if we flip those coordinates, what does that become?
+1, -1.
+1, -1. And so it's going to be 1, -1. And it's going to be, if I use my little pencil here, it's going to be this point right here. Okay, so I'm going to draw this line, hopefully straight. Okay, that's pretty straight for writing on a computer. Now, what is this point here?
Four, 3.
That's the point 4, 3. And so if we flip those points, it becomes what?
3, 4.
3, 4. So if I go 3, 4, 1, 2, 3, 1, 2, 3, 4, it's going to go right there. So if I draw my straight line, that was pretty straight. That was pretty good there. So the other thing to remember, maybe I'll use this, I should have used that one before, is remember that it's symmetric about the y equals x line. Okay, so you can see that that's a mirror image. That's how I should have drawn my lines before with that thing. What was I thinking? Okay, so that's the first one. Now let's have you guys help me with this one here. And this one's a little bit harder to draw because it doesn't involve straight lines, for one thing. So how would you guys do this one now that you've seen that one? Maybe I'll even draw my diagonal line here. Remember, it's going to be symmetric about that line.
So the 1 point is 4, -2 on the far right.
Okay, so you're starting on this side. Okay, so 4, -2.
So
And
would
that becomes what?
Does that become 2, 4, like 2, 4 or 2, -4?
Neither.
Neither.
All you're doing is you're swapping places. So it's
negative
-2, 4.
-2, 4.
So -2, +4. So that's 1, 2, 1, 2, 3, 4. So that's going to be -2, +4, 1, 2, 3, 4. That's this point here. So -2, +4. Okay. Now let's figure out the next point, which is this one here. So this point is what?
1, -1.
1, -1. So the inverse of that point will be
-1, 1.
-1, +1. So that's going to be this point, -1, +1, this point here. And now I'm going to try to draw a straight line here. Maybe I'll make it not quite as thick. Okay, so that's that point. Okay, then what?
The next point is 2, -2, 2.
Oh, you forgot 0, 0.
Oh, yeah, 0, 0.
Yeah, don't forget that point. Okay, so we're going to go back to the point now. You can see that this curves this way, so the mirror image would be kind of this curve right there. Okay. Now the next point is
-2, 2.
So that's -2, 2. So what's the inverse point?
2, -2.
2, -2. So 2, -2. So that's going to be this point right here. Go back to my pencil. 2, -2. Okay. So this is going to be the mirror image of that, which is going to look like this. Okay. And then your final point is
-4, 3.
or 3, and so the inverse point of that will be
3, -4.
3, -4. So 1, 2, 3. And let's say 1, 2, 3, 1, 2, 3, 4. So it's this point here. And now I'll draw my line. That's from that point to that point there. Okay. Pretty good for. Okay. Does that make sense?
Yeah, thank you.
I'm gonna ace my final.
If this question's on there, yeah.
Okay, good. All right, what else you got?
So just to make sure, so we use that horizontal line test when we're doing 1-to-1, and then we do the vertical line test when we're trying to determine if it's a function?
That was correct.
Okay.
Okay. All right. Who's joining our class late? I don't know who that was. Oh, it was Camilla. All right. So what else you got?
Can we go over the question about graphing the rational function, labeling all the asymptotes, intercepts, and holes? It's just down past the rational zero theorem questions.
What page is it? You're talking about the UVE
Yeah, on
thing?
the UV. Yeah. Mine says page 8, but they were different yesterday.
Page 8.
So it's probably like page 6 for you.
This is page 6. So graph the rational function. This one here, number 7?
Yep.
Okay. Graph the rational function. Show all the asymptotes, intercepts, and holes, if any. Okay, so I'm trying to decide where's the best place to do this. Okay. We'll go back to Excel and see how that works for a while. I might have to switch over to Paint to graph it though. Okay, so I've got this function here. And so where would we start with this?
I would factor them.
Okay, let's factor the denominator first. The denominator factors into
X times X minus 3 times X plus 2.
X minus 3 times X plus 2. Okay. And then what?
The numerator factors X plus 2 times X minus 1.
Plus 2. Okay. So then what?
Well, the X plus 2's canceled. Does that mean there's a hole there or an asymptote?
Oh, that's a good question. What do you guys think?
I think it's a hole, but I'm not positive.
There's a hole. The hole is yeah, where we have the same factor on the top and bottom. So the hole is X equals minus 2. Okay. All right. So that's good. So what else? We probably should keep going with our asymptotes. Let's figure out our asymptotes. Where do we have asymptotes?
at 3 and 0. X equals 3,
X
equals
equals 3. Yeah, let's make sure we say that. And X equals 0. Are there any others?
Is it still x equals -2? But there's a hole there.
So you could call that an asymptote, but since we're calling it a hole, I guess we won't call it an asymptote. But there's another one that I'm looking for.
Is it +1?
No.
X equal 3.
We've already got X equals 3 right there.
Would it be x equals -2?
Well, we've already got our hole with X equals -2.
Could it be 0? Oh, you got the 0 already. 1?
You guys are guessing now, right? I told you there's one more and nobody can figure it out. Okay, here's your hint. Compare your degree, your numerator with your degree of your denominator.
It will not be y equals 0.
Y equals 0. So we've got an X equals 0 and a Y equals 0. Because if we just look at this, the degree, it's 2 on the top, 3 on the bottom. That simplifies to 1 over X, which goes very close to 0 as Y gets really big. Okay? All right, so we've got all three of those. So asymptotes, intercepts. Let's talk about intercepts.
So are asymptotes only on the denominator?
Our vertical asymptotes, so these are our vertical asymptotes right here, those two. This is our horizontal asymptote.
Oh, okay.
Yeah, so we need to distinguish there.
And the vertical will be on the bottom?
Those verticals always in the denominator.
All right.
The horizontal, you look at the degree of the numerator and the denominator, and then you see what happens to the fraction.
Oh, okay. Sounds good.
Okay. All right, so how do we find intercepts?
You substitute y and x for 0, right?
That's correct. So I set X now. So I guess it's pretty easy to say, since I've got asymptotes at X equals 0 and Y equals 0, I'm not going to have any intercepts. Because clearly, if I've got asymptotes on the x-axis and y-axis, I'm not going to have any intercepts. So there's going to be none. But if you didn't know that, set x equal to 0 and solve, which 0 is a problem in the denominator. Set y equal to 0 and solve, and obviously y is a thing. We can see, though, you could check and see if it crosses. Check to see if it crosses the horizontal. Okay. So even though, I guess my guess is here, it's probably not going to cross, but it is possible. Okay, so I'm going to set this whole thing equal to 0. So if I set this equal to 0, then the denominator, if I multiply by the denominator, the denominator goes away. So can x plus 2 x plus 2 times x minus 1 is going to equal 0. Okay? So x equals -2 or +1. So does it cross? What do you guys think?
Yes.
It does cross. So it does cross the horizontal asymptote because, so it can cross the horizontal, it will never cross the verticals. Okay? So this is interesting because we got a hole here and it crosses at these two spots. Okay? So at this point, let's start drawing this. I think I will use this. Okay, so we're going to see how straight my finger is here. Not very straight. Okay. So I've got a horizontal asymptote and a vertical asymptote. I've got a horizontal asymptote at 3. 1, 2, 3. And I've got a hole at x equals 2. Now that's funny. Oh no, I guess it's not that funny. Okay, so at x equals 2, I've got a hole. I need to figure out where that hole is. So at this point, I'm going to cross out this, and I'm going to solve the rest of that. And I'm going to find out where the hole is. Okay. So if I go back to, oops, I didn't mean to build that, but that's okay. So I'm going to let -2 equal to -2 equals x minus 1 over x times x minus 3. I need to solve that equation so I can find out where my hole is. Oh no, that's not exactly right. I do cross out those two, but I'm going to plug in x equals -2 into this equation now. And that will tell me what the y is, okay? So if this is my fraction, I'm going to have -2 minus 1 on the top, and I'm going to have -2 times -2 minus 3 on the bottom. Just go away. Okay, so this becomes -3 on the top. -5 times -2 is +10. And so that's what my y equals, okay? So my y is going to equal -3/10. Okay, so this is why I am perfectly fine with you guys. If you want to draw an asymptote at x equals -2, I'm fine with that. It's technically it's a hole, it's not an asymptote. Let me draw. But I guess if I want to be super accurate on here, so if this is -1, I've got a hole very close. I can't even see that. That's a big hole. I can't draw a small hole on this with my finger. I've got a hole. That should be about 1/3 of the way. It looks like maybe I'll draw. Here, I'll make that a little bit bigger on my scale. Now, that looks a little bit better. I've got a hole there. Okay.
Should that's at 2, right? Shouldn't it be at -2?
Oh, you're right. I'm on the wrong side. 1, 2, -2, and my hole should be about right there. That's correct. Thank you. Good catch. Okay. All right, so now what do we do? Now we just need to start plugging in points. Now at this point, since I know where my hole is on the left side, okay, I can probably just keep drawing here because it's not going to cross the x-axis again. We do know that it's going to cross at +1. At +1, x is 0, so it's going to cross right here. So now I need to draw, so I've got an asymptote here. Well, I just need to figure out what's going on here. I'm going to draw a huge circle here. What's going on? Luckily that didn't actually draw, but this area here, hopefully you can see this thing. Okay. So the area between x equals 0 and 3, we need to figure out what happens. So let's pick a number like 2. Plug x equal +2. Now, it doesn't matter. I can use the simplified fraction, or I can go back up here and I can use that. It doesn't matter. Okay. Because the 2's are going to cancel, so I'm going to use the simplified one. This is going to be 2 minus 1 over 2 times 2 minus 3. 2 times 2 minus 3. Okay, so 2 minus 1 is 1. 2 minus 3 is -1 times 2 is -2. This is going to be -1/2. Okay. So the idea here is at x equals 2, y is -1/2. So if I draw, so I'm going to be below the axis here at -1/2. Okay. And I know that I'm going to cross my axis. So more than likely what's going to go on here is I'm going to go down, I'm going to cross, and I'm going to go up like that. Okay, if you're not sure, pick a point between 0 and 1, such as 1/2, and you could plug it in there. But I'm sure that's going to work. Okay, now and it's hard to tell. I guess I should fill that circle in so you know that's not a hole. So this is a hole here. That's not a hole. And maybe I should fill that in too so you know that that's there. That's not a hole either. That goes through those 2 points. Okay, but this is a hole at the x equals -2. And now finally, I know that in this area, it's either going to go like this or like this. How do I figure out whether it's above or below the axis?
Plug in a point.
Which point?
Can you do like +4?
Exactly. X equals 4. I'll use the simplified fraction. 4 minus 1. Dang it. 4 minus 1 over 4 times 4 minus 3. So 4 minus 1 is 3. 4 minus 3 is 1 times 4 is 4. So I'm positive I'm at 3/4. So it's definitely going to be above the axis. And now maybe I'll draw it a little bit more L-shaped than I did the first time. Oh, that's terrible. There we go. So there you have it. Okay. That was a good one. That one had everything. Okay, what else you got? Let's see if anybody's waiting. I heard it beep. Oh, looks like everybody's here. Okay.
Just below that, I think there's some graphing log functions, or like using transformations with logs.
Okay.
Can we just review that real quick?
Okay. Which one do you want to do?
Let's just do the first one.
The first one. Okay. Actually, maybe I'll try to copy that graph. That might be really helpful. I think it will actually. Okay, so if I pick another new page here. Oh, wow. Okay, I think the main thing, if I can pull this out here, I don't care about the rest. Okay, so I've got my function here, which is a log function. Identify the y-intercept, if any. So how would I do that?
Just plug in 0 for x, right?
Plug in 0 for x. So if I stick a 0 in here, what's the log base 2 of 4? Or let me back up again. Yeah, we're plugging in a 0 for x, right? So that's going to go away. So what's log base 2 of 4?
I've got no clue.
No clue. Oh, that was...
2.
I'm sure you're not the only one. Good. It is 2, right? 2 squared is 4. So the log base 4 of 2 is 2. So 2 plus 1 is 3. Okay. So the y-intercept is going to be x equals 0, y equals 3. Does that make sense, Logan?
Yes.
Okay. All right. Where's the asymptote? Maybe we do want to start with here. Let's go back to here for just a minute. Do we know what the basic log function looks like? Can you describe that to me? Unshifted.
Is it kind of like an exponential, but not really?
It's the mirror image of an exponential. It's a mirror image across the y equals x line. So as a review, and let me pull this over here for a minute. As a review, the basic log function, there's two things that you should know. The important point, remember, because I couldn't remember something else, and you need to know the asymptote. So what's the important point for the log function?
Zero, 1.
No, because if x
Is
is
it
0,
1,
you're
0?
gonna get, it's 1, 0. Very good. It's 1, 0. Okay. So if x is 1, y is 0. Okay. And your asymptote is going to be where?
Is it x equals 0?
X equals 0. Okay. So if I'm drawing on here, I've got an asymptote. I've got an asymptote on the y-axis, and it's going to go. Well, that didn't go through 1, 0 though. Try that again. That's pretty good. Getting closer. Hard to draw this with your finger. Oh my gosh, I cannot get it through that point for anything. Ah, I did it that time. Good enough. It's probably it's actually way too steep. I'll try it one more time. That's pretty close. Okay, close to there. I was trying to get it through the 0.01, but it's close enough for what I'm trying to do. So that's your basic log function here. I thought it was going to let me draw. Come on, stinker. Draw. That's the basic unshifted. That's your basic function right there. Okay. Now, when we're taking this function here, we'll do this in red. Okay. What does this 1 do to me?
Shifts it up 1.
Shifts it up 1. So now, instead of going through this point, I'm going to go up 1. Okay. What does this -4 or this +4 do to me?
Left 4.
It's going to shift it left 4. So my asymptote's going to shift left 4. 1, 2, 3, 4. So I've got a new asymptote right here. Boy, that's a terrible looking line. And my important point is going to shift up 1. So now it's going to look like that. That's terrible. That's what it's going to do. Okay. So now that we know this, in fact, I drew it before I showed where my equation of my asymptote was. So what is the equation of my asymptote now?
One plus log base 2 of x plus 4.
That's not my asymptote.
Oh, sorry. I didn't mean to have the microphone.
So what's the asymptote?
X equal 4.
X equals
Oh,
-4.
minus negative.
Okay. All right. So now what's the domain and range using interval notation? So the domain, let's do that one first.
That would be parenthesis -4, comma, infinity, right? Parenthesis.
-4, comma, infinity. I'll just do infinity that way. And what did you forget?
The x is an element of, and a
I
parenthesis
don't know
after
how I'm going to
infinity.
draw x as an element of. So x is an element of -4 to infinity. And your range,
That's just parenthesis -infinity to infinity. Parenthesis, y is an element of.
y element of -infinity to +infinity. Okay. Oh, see, I sketched the graph. I can't help myself. I got to sketch the graph right off the bat. Okay. So the main thing that I'm looking for is, do you have the important point, which is that point right there? And is the basic shape okay? And do you have the asymptote in the right place? So those are the 3 main elements that I'm looking for when you guys are drawing these. And hopefully you don't have to draw them with your finger. I'm sure you won't. If you're drawing them with your finger, you got a big problem. Okay. All right, we've only got a few minutes left. Do we have a good, easy, short question?
I do just have a quick question that you don't have to graph or anything, but on the problem below that, it's 2 to the x plus 2 power. So does that x plus 2, does that shift it left 2?
Okay, here, I'll copy that. Let's talk about how it shifts. Okay, so
Because obviously it shifts down.
it's going to shift down 1.
Yeah.
That's correct. And
left 2.
2. That's correct.
Okay, so whatever the power, whatever's in the exponent power, that's your like left and right shift.
Correct.
Okay.
All right. Any others?
Can you write that equation in log formation?
Can I write it as a logarithmic equation?
Yes.
So you're asking for the inverse function? Is that what you're asking for?
Yeah,
That's a
I
good
guess.
question, actually.
Yeah.
Find the inverse function. How would you do that? It's a really good
I
question.
can't remember.
Okay. So we need to swap our x and our y, right? Swap x and y. So now, remember, g of x really represents y. So I'm going to say x equals 2 raised to the y plus 2 power, y plus 2 power minus 1. So how do we solve that? We need to solve for, so at this point we need to solve for y. I guess I'm going to have to hurry since we're out of time here. Any quick ideas? This one's going to be really hard to do up here. We're going to take the log base 2. I'm going to put B2 for base 2 of x. Log base 2. Actually, no, I'm not going to do that. I need to get rid of that 1 first. So I'm going to go add 1 to both sides. Add 1 both sides. So that's going to give me x plus 1 on the left equals 2 to the y plus 2 power. Okay. Now I'm going to take the log base 2 on both sides. So that's going to give me the log base 2 of x plus 1 equals y plus 2. Y plus 2. Okay. Now, if I get that y all by itself, I need to subtract 2. So this is going to be log base 2 of x plus 1. And then I'm going to subtract 2 equals, now I've got f inverse of x. Really hard to do notation on this without superscripts and subscripts. But that would be the inverse function.
Okay, thanks.
Okay. Now, what would be a really good question is if you could draw both that equation and this equation on the same graph. That would be awesome, but we're out of time. Okay. So, any last questions you guys have? Alrighty then. Well, everybody, looks like most everybody stuck around today. So I'm going to give everybody 1 point on the quiz today for being here. And we'll see you all tomorrow. So as far as tomorrow goes, I thought we were going to go over the first multiple choice review. So you can do that tomorrow. But so I guess we kind of did today, but we didn't. Nobody asked me any questions on it. So tomorrow will be the rest of the other 3 review sheets. So, or if you want to keep going with this one and dive in deep, that's fine too, I guess. But We'll see y'all tomorrow.
Thanks.
Mm-hmm.
Thank you.
See ya.
See ya.